Okay, so let's start with the idea of the situation in which if we have a triangle and we said that the length down the bottom base, for example, that being the base, and the height would be something like this. What happens if you have been given, that being the height, what happens if you have been given a triangle wherein the lengths, considering that that is the base and this is the height, when the lengths of the sides change significantly, so you have now something like this, then, for example, the base has stayed constant, that's fine, but how do we describe the height here? So first of all, let's tackle that by suggesting to you that this length here is the same as this length here. So that, if you were to measure that instead of the red triangle, so we are only caring about, in these circumstances, the red triangle. Now, for the red triangle, if you were to measure that instead, I'm coloring it to green within, so I probably need to be careful with the language I'm using for my description. But for the red triangle, red outside, or green now, let's be more specific. For the green one, what you would need to do is you'd need to calculate that height from the center of the base all the way to the top, because as you can see, that height is going to be the same. And so that's how you could do that. You can therefore say that this is here, this is equal to height, and this is the same for our right angle triangle, in which we've derived half base times height, because base times height would be the square, half base times height would be this right angle triangle. But if you used the length from the top to the bottom, you can use that as height. Base is the same, this should still hold. However, sometimes it is not advantageous to calculate this height first. In this problem, for example, calculating that height first will cause serious levels of increase of mathematical lines if you were in an exam, and in those situations the probability of you making a mistake goes up significantly. You would have to find out what this length is here, then divide that by 2, find out what that is. It seems to be a little bit cumbersome. In so doing, in order to find this length, is how do you get that information without some serious thought? And in many situations, if you have not been given an angle, which you haven't in these circumstances, finding that length could be an extraordinarily difficult thing to do. Now, in these circumstances, what we're going to do instead, and when I say extraordinarily difficult to do, I'm being a bit relaxed. I would perhaps even use the word impossible. You have two sides and no angle, so you can't use sine or cosine rule. So in these circumstances, what you want to do is you want to figure out how you can utilize the fact that we're aware that the angle in here has changed. That angle in there has changed. There, it's gone from this small one up to the blue to this one all the way to the red, and this length here has also changed. So if we have the capacity to figure out these lengths or an angle, it might be easier to work out the area rather than using area as base times height. So let's take a look. As we've suggested, the height for a right angle triangle can be considered to be the same in this circumstances. So if you want to use base times height, half base times height, then you could work that out. But I would not do that in the majority of these cases. Instead, I would consider that if this is the angle in here, that angle in there, if that is the angle, then what else we can consider is that that this line here from top to bottom is the opposite of the angle. So rather than half base times height, which I would have otherwise put a h in here, instead of doing that, I'm going to put O in here to represent that it's the opposite side. So this is equal to the opposite side of that angle. Now, given that that is the case, and we have worked out in the last lesson that since sine theta is opposite divided by hypotenuse, multiply both sides by h, you get h sine theta equals opposite. I can actually then say opposite is h sine theta. There is nothing stopping me from making that claim as a result of, in these circumstances, it being true. So there you have, we have half base times h sine theta. But this height, h, as you can see here, that would be our h. In these circumstances, what was h? Where did we get h from? H was this. It was hypotenuse. We're using trigonometry. We're not using height as h, and I just need to make that clear because sometimes those things can clash. We were using trigonometry. H was this hypotenuse. I'm going to make it very clear. I'm going to give you a bright red for it. H was the hypotenuse there. That is h. This is O. So when I use h sine theta, I'm talking about the largest line that touches the angle. In these circumstances, the largest line that touches the angle is there. That is h. Next, what is theta? Well, theta is this angle in here, which I've colored blue. That is what we've decided to be theta. Base is the same as what we've always been saying. The bottom part of the triangle is the base there. So in these circumstances, I can say this is base. That is base. So there is your base. And the half, we know where that's derived from. That's derived from the original position of this square being broken down into two right-angled triangles. So you only need half of the area. So this is our new equation. And we sometimes don't use B and H. We can use B and C. We can use A, B. We can use any letters we want. And so what I will do is I will make that clear by illustrating here that any letters can be utilized, but there is a pattern in the letters in that it still sticks to the logic of what we were saying. If you look at this diagram, and we need to pick, this is perhaps one of the most important parts of the formula. The angle is enclosed by this line and this line. I say that again. The angle is enclosed by this line and this line. That is always the case for this to be true for the reasons of the descriptions we've been saying before. So that is the case for this. The area, if the area is going to use angle C, so here you see angle C. Let's make this clear on here where angle C is. There is my angle C. Here you see angle C. So according to what we've just described, from what we said, the lines must be enclosed on that angle. That line and this line wrap round that angle. And so this is going to be the case here. I'm going to bet you that this line is B, that is enclosed on C, and then A. So it should be a half AB sine C. Let's do another one to illustrate that this point one more time, drive it home if you will. If I was to pick B, let's take these away. If I was to pick B, then if I show you B here, the lines that are enclosed for it to work, you'd need the length of A and you'd need the length of C for it to work. And notice it is AC sine B. So it doesn't really matter what letters you wish to use, just remember that concept. The concept is that whatever angle you have, the two lines must enclose upon it. And that comes from the idea that sine theta is opposite divided by hypotenuse. That is the that is the hypotenuse. It touches the angle. This is opposite. Because opposite has been, we multiply both sides by h to find h sine theta is opposite. We then looked at the concept of a half base times height. Notice that the base is always going to be the bottom line. So here you have the base and you have the hypotenuse and you also have the angle, and they wrap round, the base and the hypotenuse wrap round that angle opposite. Well, this is what happened to opposite. We had half base times height, which was this opposite side here, or the length in here. And what we did was we took opposite and we said, no, we can substitute that out for h sine theta. So it disappeared and all that was left was the base and the hypotenuse. And so that is why it will manifest itself in any pattern. If I wanted A, I need to do sine A multiplied by C times B and half it. And so the most universal one that you'll find in your textbooks or in any circumstance, namely, is half AB sine C. Alphabetically, it's easy to recall in that sense. And it just means if you have an angle C, make sure that A and B wrap around it, multiply it by half, and use sine c, and know where that comes from now. That comes from the use of this trigonometric function. Okay, so now we're going to tackle this one, and we'll do that in the second part of this video.